This presentation looks at what we are calling the virtual terminal conundrum and the efforts that companies take to resolve it. For the purposes of the deck, we only address third-party virtual terminals. However, the reality is that the same issues exist and the same controls must be in place for agents to connect to any application, whether hosted internally or by a third party, and the DataDivider Isolated Access Terminal solution is an effective control either alone or combined with other DataDivider tools. So what is the virtual terminal problem? Per the PCI Data Security Standard, anything of yours that stores, processes, or transmits cardholder data is in scope for PCI DSS, and workstations used to process transactions are functionally point-of-sale registers. At least 10 of the 12 PCI DSS requirements apply in a typical virtual terminal scenario. IT ownership is often decentralized and comprised of multiple different operating systems, applications, and networks, and most organizations have mixed-use workstations, used for both routine and high-risk tasks. As you can see from the diagram, one single agent using a virtual terminal application within a typical merchant environment can bring the entire network and its connected devices into scope for PCI compliance. This is time-consuming and costly, and the sheer number and complexity of controls usually cannot be justified or even achievable. There are multiple possible solutions that most organizations have considered when looking to resolve this problem. Each of them comes with additional problems of their own. Option 1. The first and most obvious option is to implement each of the controls as they appear within the standard within your agent workstation environment. This would typically encompass 10 out of the 12 requirements, or upwards of 200 security controls, including antivirus, patch management, personal firewalls, physical security, disk encryption, centralized log management, and file integrity monitoring. This option is typically the first to be rejected due to cost, usability issues, and lack of skilled engineering resources. Option 2. Dual workstations and dual network. This scenario requires a lot of additional hardware and still requires each of the PCI controls to be implemented just on a smaller subset of workstations. Requirements 2, 5, 6, 10, and 11 still apply. The cost, space, administration, and user acceptance make this option only slightly more desirable than option 1. Option 3. Use a hypervisor. Virtual servers and networks require the exact same controls as standard systems. Knowledge and administration of dual networks, different trust levels, and mixed-mode environments is required, as well as remote decentralized administration. This can end up being more difficult than both options 1 and 2. Option 4 is to use a USB device. Secure USB devices are great, but not for enterprises hoping to achieve compliance. Add into the control mix device management, network segregation, more patching, more logging, centralized management capabilities, key management, and distribution management. And finally, option 5, the secure browser. As with USB devices, secure browsers are not purpose-built for PCI and do not compensate for PCI controls. Keyboards remain in scope, the local desktop is in scope for the assessment, and it is possible to launch sites without launching the browser. So what is a viable solution? Just as the name DataDivider suggests, the sensitive data is divided away from the merchant or agent's network and workstation so that the VT and the network it connects to are taken out of scope. DataDivider is a compensating control for your existing virtual terminal so that the workstation, keyboard, and screen are isolated and there is no chance to log keystrokes or capture screenshots. DataDivider is secure and PCI compliant, QSA approved, and fully hosted within a PCI compliant data center. Here is a schematic of what is going on with DataDivider's Isolating Access Terminal. Without changing anything about the agent's workstation or network, we can simply and quickly insert DataDivider between the workstation and the processor, reducing scope and the need to implement other costly controls. The agent who is processing the cards launches IAT, and by virtue of doing that, they are not bringing the local network into scope. Instead, the data is entered directly into the DataDivider environment and passed on to the virtual terminal. How does IAT work? Merchants connect to DataDivider via SSH. The SSH tunnel opened on local port for moving HTTPS. The HTTPS connection is made to a supplied URL. The secure browser session is launched and downloaded on demand if required. The Microsoft RDP ActiveX client is downloaded on demand during first use. The secure browser provides a protected connection via the embedded RDP ActiveX client. The ActiveX client is routed through to the appropriate RDP server. Users can now authenticate to the RDP server using their own individual accounts. The merchant launches the virtual terminal connection within this remote desktop, hosted by DataDivider. The RDP protocol is running over HTTPS within the secure browser, within SSH. The merchant connection to the VT is from the remote desktop, not the local workstation. Any data on the user desktop is destroyed at end of the secure browser session. There are two main ways to use IAT. The first option, as already described, is a secure remote desktop protocol, or RDP session. The user connects over a secure, locked-down browser session into a remote desktop within the DataDivider portal. Once authenticated, the user is sent their IAT profile from the profile manager that is protected within the portal. The IAT browser session checks the local machine for malware during launch and shuts down any suspicious processes and applications. The IAT then runs in a protected memory space, monitoring external activity, and shuts down anything that looks to be trying to tamper with that memory space. The IAT memory is securely wiped at the end of the session. Each user has a profile that prevents any data leakage from the session, such as screen scrapes, cut and paste, and key logging. Once the user authenticates to the secure desktop, they open their browser shortcut to their virtual terminal, and all unauthorized browsing or other activity on the desktop is prohibited. There is a second option to use IAT without the SSH tunnel. The user launches the secure browser, authenticates with DataDivider over an SSL VPN, is sent their profile, and then the traffic is forced back through DataDivider to their virtual terminal payment gateway. This solution does not involve a desktop at the portal and only allows for one directional connection to a virtual terminal. The session is completely protected from any malware or data leakage, and the memory is deleted when the session ends. While the actual activity is still local to the workstation, it is not accessible to the workstation or local network. It operates effectively as an isolated shell transmitting over a double SSL tunnel. The DataDivider keypad is integrated into the secure browser session and can be programmed to perform a number of different tasks. The keypad can be directed to launch on specific designated fields, directed to disallow any other input into those designated fields, and can mask data input. The keypad can also tokenize the data and mask the target fields in the third-party virtual terminal applications. The keypad can also be programmed to talk to internal IVR systems to ensure that the card data does not get recorded. The visual key presses on the keypad can be disabled to prevent shoulder surfing during cardholder data entry. Users are restricted to clicking on the keypad numbers that transmits them to the virtual terminal fields all within the desktop session. Mouse clicks cannot be captured due to the security controls within the IAT browser session. Nothing can be electronically taken from the IAT session. The secure browser protecting the session is an on-demand security agent that protects browser sessions from data theft or data leakage. It shields sensitive data from keyloggers, session hijacking, cache miners, other malware, blocks inbound attacks, and places strict controls over the saving, forwarding, printing, and screen capturing of browser-delivered information. The memory is completely cleaned up at the end of a browser session, leaving behind no remnants or modifications to the user's desktop. Security is enforced only within the secured browser. No other browser instances or applications are affected.